And welcome to the Knowledge Trailblazer, where we look for interesting civil engineering related topics to share with you. This is part of the SAICI Growing Forward initiative. If you're not a member of SAICI, please do join us. The link to the membership and to SAICI is down in the description below. And please like this video, hit the subscribe button, and turn on the notifications so as soon as the videos come out, you will then be notified of the videos. In today's topic, we'll be talking about 3D concrete printing. It's printing buildings and structures and elements with concrete. Yes, you heard me right. Printing with a printer. It is a very big printer. And to talk to us today about 3D concrete printing, we have Marchant van den Heever, a PhD candidate at the University of Stellenbosch, and 3D concrete guru. Hi, Marchant.
Hi, Tauqeer. I'm very well, thank you. Very pleased to be here.
Thank you for coming and joining us and talk to us about 3D concrete printing. Before we go into the topic of what exactly is 3D concrete printing, could you maybe just tell us just a little bit about yourself? Who is Marchant? What is it? What do you do? And why 3D concrete printing?
Absolutely. Thank you very much for the opportunity. And the introduction. So a brief introduction about myself. I'm Marchant van den Heever. I'm a PhD candidate in the Division of Structural Engineering and Civil Engineering Informatics at Stellenbosch University. And my research focus is the structural performance of modular 3D concrete printed components under moderate seismic action. So essentially what all of this entails is material design and testing of 3D printable cementitious materials, and then also the mechanical characterization thereof, experimental and computational mechanics. So how do you test these and how do you model this in finite element simulations? As I said, numerical simulation strategies for 3D concrete printing. Looking forward, how do we assess the structural performance of these components? And then also modular component design. So we've got two camps in 3D concrete printing, one that advocates for on-site printing and one that advocates for off-site. I'm in the latter camp, and so I'm looking at modular 3D concrete printed components and their design, and then also large-scale experimental testing. So as you see, there's quite a few realms that I have some fingers in. But it's very exciting research, and we're essentially looking at bringing 3D concrete printing to a feasible stage, which makes it accessible to the sort of broader market. So to get into it.
Yeah. Maybe before we continue to this next slide, thank you for the presentation. With respect to now the different components, so are you looking more specifically at researching into just components of a building, or looking at a whole building as well, or where specifically are you looking at coming into the side of 3D printing?
Yeah, so in the general term, you look at both. There is application of opportunity for application in both sectors. I specifically am looking at modular components. So how to break the building up into smaller pieces and then assemble them on site.
So basically like building blocks. So you're going to create components for a building and just assemble on site.
Absolutely, same as conventional prefab construction. Just looking at actually fabricating these components with 3D concrete printing technology.
Okay, I see you touched on something that related to seismic level. Is there a specific seismic level that these buildings are able to withstand, or that's still something that's being researched?
Yeah, so that is one of the topics of my research, is then to sort of validate that these components can withstand the seismic loading that they are designed for. So we are in, well, myself in Cape Town, or in Stellenbosch, we are in a moderate seismic region with a peak ground acceleration of 0.15 G. So my research looks at designing components to withstand these seismic actions.
Interesting. No, thanks for that. And I see you got some nice pictures up here. Can you just take us through this slide?
Yes, so over here I've just got a quick slide of some of the projects that we've done. On the furthest left, you'll see a facade, which is once again a modular design. And essentially you just print these flat objects and then assemble them on a steel frame. So the concept sort of illustrates that you can have these geometric patterns. The size of each individual component is completely customizable, and then you can design it to allow a certain amount of light or air, or wind through, and you could angle them if you'd want to only allow certain angles of light to enter your building at certain stages of the day. The two flamingos that you see here is a concept where we explored the free-form capabilities of 3D concrete printing. This is literally a line drawing that we drew, converted it to a digital format, and then printed to sort of showcase more the artistic side of 3D concrete printing. Sort of center at the top, you'll see a 3D concrete printed panel. Now, this is one of my modular components that I've designed. And essentially, this is one of those building blocks that you referred to that would make up a shear wall to resist your induced loading. So this is a lateral resisting member, and it's designed as a bending dominant wall to then obviously dissipate the energy in case of a seismic event. At the top right is we call it the X-Bench project. This is something that we developed for the university, where we once again showcase the free-form design as well as using cellular structures. So you can see there on the table, we use a truss-like structure to distribute the loads on that table, and we tested it, and at 7 days, it took 3.4 tons. So this is proper strong, and it's only reinforced with high modulus polypropylene microfibers. At the bottom, you'll see sort of a picture of one of my colleagues, Frederick Bester, where we're doing some experimental testing. We develop these components and then we physically test them to determine their mechanical capacities. And then the bottom to right are the two printers that we've developed at Stellenbosch University. So due to the high capital investment that you require for these machines, we've adopted a very hands-on approach at Stellenbosch University where we physically build our own machines. So the first one is a 1 by 1 meter gantry style printer developed by Dr. Tauqeer. And then the second one is our new printer, which will probably be up and running at the end of this month, which is a 3 by 3 by 3 meter gantry printer, which is located in our concrete laboratory at Stellenbosch University.
Interesting. And just now with I've got a couple of questions that I want to maybe also raise now. When it came to building your own 3D printers, how did you go about doing something like that, and what was the requirement? Because I understand obviously you are a civil engineer, and I'm sure you had to touch on robotics and mechanics and all of that.
Absolutely. I think nowadays we've sort of embarked on a time frame, or a certain where we are in the global economy at the moment. You sort of have to adapt and be an engineer, a general engineer. So if there's a problem, you create solutions. And in this case, the problem was the printers are very expensive, and the solution was we'll build our own. We leaned heavily towards conventional plastic 3D printers, gantry type 3D printers. We just scaled the frame up to a more structural and durable machine with, steel members. And then the essentially, we've got firmware which we run, which is it's all freeware. As I said, we really do take a hands-on approach. And then you design the printer. Obviously, you've got your motors and your drivers to make this machine move. And then you've got a control box, which is essentially the brain of the whole machine. And then that essentially interprets the G-code file, which you send to the machine, and then creates the object. So
interesting. Now, if you think about it, just to touch on a couple of points of what you raised, and look, the way the industry is going, we headed down this road of the fourth industrial revolution, becoming more automated, and then moving towards this new technology. Like in a sense, yes, we are civil engineers, but we need to start becoming general engineers. Or start adapting, robotics and mechanics. It's similar to one of our colleagues out in University of Pretoria, Andre Broekman, where he was also looking at combining electronics and artificial intelligence with civil engineering. So it's quite similar, I must say, in this respect as well. In that this is the way that we are headed as civil engineers, and for us to then become more innovative, we need to then start learning these other fields as well. And it's quite interesting now what you also mentioned, that these things are quite expensive, and we had to make a plan as South Africans. And I think that's something quite classic for us as South Africans, in that we always are quite resourceful, and we always make a plan in terms of all these different things in technology. So I must say South African innovation is always at the forefront of our industry. And like you just proved it again. We just continue making a plan this side, and then doing our own thing.
Absolutely.
Yeah. And with your freedom of form that you were showing early on, I take it there's no limitation in terms of any shape that you can achieve?
There are certain constraints, but these will be mainly based on your material requirements. So physically, at what gradient can you print? And this is very dependent on, say, the stiffness of your material, your layer geometry, the speed at which you're printing. It's a very interconnected process between the fresh state material characteristics and then also the structural performance or the structural integrity of this component. And these are all considerations. So theoretically you could print it, but whether or not it would be structurally sound in certain cases, you would then have to verify. Hence the focus on numerical simulation strategies for 3D concrete printing.
Yeah, but from an architectural point of view, if you want to create some unique shapes, that obviously is a bit impossible to do with formwork, you've got the freedom, at least with 3D concrete printing, to be able to achieve forms that you're not able to do so with conventional formwork.
Absolutely. So here in my next slide, as I sort of showed to you, and I say, what is 3D concrete printing? So this is a form of additive manufacturing. Like I said, basic plastic printing principles, where you physically deposit one layer onto the next, creating a sort of a contour that gains height as the process develops. And this is used to fabricate buildings or construction components. So as we said, you can either go prefab or you can go in situ concrete printing to create completely new shapes, which were previously impossible with traditional formwork. So with traditional formwork, we tend to sort of favor rectilinear designs because these are standard components. It's easy to design for, it's easy to fabricate. Now with 3D concrete printing, what we're proposing is that buildings don't have to be rectilinear anymore. Components can physically fit in where you desire them to. This opens up tremendous opportunities for, say, the retrofitting perspective, and which would hopefully add value to the construction market. Yeah,
and again, it allows that freedom and artistic, if you want to call it an architectural type of freedom for you to then create non-conventional shapes and be free to create whatever form you want. So yeah,
Absolutely.
again, like we mentioned earlier, things that are impossible to achieve with traditional formwork. There's no limits in this respect. And I just want to check now with obviously now you mentioned now when it comes to the 3D printing, the material you print with and the rate of printing and the deposit layers has also quite a strong impact in terms of how you can print. With that in mind now, is there a limit in terms of how long a print can be or how high a print can be that you can achieve within an hour or day or maybe?
I think this is a topic for, we can do a whole next presentation on this one.
Okay. Okay.
I actually have quite a few notes that I can share, but
Okay.
theoretically, there is no limit to how high you can print, well, except for you're going to have to be building bigger and bigger machines. This is
Okay.
also then, once again, why we advocate for modular construction components, because every time you'd like a bigger structure, you won't necessarily need a larger printer.
Yeah.
Based on how long a print can be, there is theoretically no limit to how long a print can be, as long as you have a constant material supply that you are assured of a certain quality standard. The print can continue as long as you need it.
Okay, interesting. I guess it makes sense when you put it that way. In terms of obviously the limitation being the size of your printer will then determine how big your component you build. But then again, if you want to try and build a whole big building one time, there is a limitation in that it's if do you have the money to make a bigger printer, or do you just box smartly, you make smaller modular components and you just put the building together and you can still achieve a bigger building but with a smaller printer. So I guess it's just yeah, scale of economies.
Absolutely, absolutely. There are some additional considerations like connections. If you do take on the modular aspect or sort of methodology, but this is it's a very mature sort of segment of civil engineering is connection design, and we have it's quite easy to generate solutions.
Yeah. When it comes to putting these components together, the strength and the reinforcing of an element, um, is there reinforcing in it, or is how is the strength normally achieved when it comes to those modular wall elements?
Yes, so there is reinforcement is incorporated, and there are various methods in which you can incorporate this. I'll We'll do another presentation
Okay.
on all the different methodologies that we have, and sort of what considerations you have to take to ensure that this is integrated in the 3D printing process, and how it is integrated to uphold to the advantages of 3D concrete printing. But definitely we do reinforce our components.
Okay, so there is an element of reinforcing at least.
Absolutely.
Okay. Please take us through this slide you've put up here for us.
So this is just a general, we've sort of briefly touched on it, but how concrete printing works. So you have your CAD design, you have this object that you have created from your idea. And then essentially you take this object and you create an STL file. So this is a standard triangulated file, which sort of accounts for the geometry of this object which you would like to create. And then you have a sort of a slicing software which breaks this component up into layers that you physically want to print. And then that generates the machine readable file, or in our case, that's G code. It's the same as CNC, the same language that CNC machines use. And then this is fed into the 3D concrete printer, which then has your firmware, which interprets it. And then your 3D concrete printed object is produced. So what's very significant about this is the whole value chain of design at the moment, before construction, is digital. It's digitally native. We design on computers, we communicate on computers. Now, essentially, what we are advocating for and trying to promote is extending this digitally native platform to include the construction process as well. So, and this has quite a few advantages, which I'll briefly touch on in some of my later slides.
Okay.
However, now, but when you 3D concrete print, there are a variety of considerations that you should bear in mind. Now, I have the slide here where you can see there's 4 labels, A, B, C, and D.
Okay.
So, and this touches more on the material side and then the structural integrity. So, A, pumpability. Whether or not this mixture that we've created can physically be pumped without segregating under high pressures. Does it retain its mix design? Does it physically retain your intended material properties? Then B, can you physically extrude this material? So can you agitate it enough to get it into a flowable state to actually then be able to deposit, you know, the material where you'd like it, so it can follow the G code and extrude and then create the object. So then C, you'll see, is a term we refer to as buildability. So is this material, can it then, after being sheared, structurate fast enough for you to be able to attain a vertical building height? So this is what we briefly touched on earlier. Like I said, like you said, what is the free form capabilities? Can you theoretically print anything? This will tie into buildability. Does the geometry of the object that you desire to fabricate correspond to suitable material properties that allow this object to be fabricated? And then ultimately, the link between your fresh state properties, pumpability, extrudability, and buildability is then the structural integrity of that component. So if you take too long before you deposit the next filament, that would impair the interlayer bond capacity between the subsequently deposited filaments.
And things can then delaminate between the 2 layers, I take it?
Absolutely.
Okay.
So, and this is something that we call constructability optimization that I'll touch on in my next presentation.
Okay, perfect.
So far I've only been showing you gantry type 3D concrete printers, but there are a variety of options which, if you were to commercially, you know, 3D concrete print, and commercially we have gantry style 3D concrete printers available. You also see robotic arms, and the specific one is a mobile robotic arm, so it can physically drive around on site or in your factory and then position itself and print the component. So obviously this thing, you aren't bound to a certain print envelope as you were in the gantry style printer, because the printer can physically move around. And then you also see a crane type 3D concrete printer, which is essentially a boom that moves around, sort of, that operates more in a polar coordinate sort of a system, where gantry and robotic operate in Cartesian coordinates.
And having looked at now the technology of 3D concrete printing, obviously it's still quite new in South Africa. Can we maybe just get an idea of now internationally? Because I see now you're showing us different type of printers, so it seems as if these obviously should be on the market. What does the market of 3D concrete printing look like? Is it quite big overseas, or is it also conceptual?
Yes, it's very big. I can skip ahead to this at the moment. So the current market for 3D concrete printing is $311 million, estimated in 2019 by Allied Market Research. However, the market is expected to reach 40.6 billion by 2027. So in a period of 7 years, there's an expected cumulated annual growth rate of 106%. That means the market will double every year for the following 7 years. This technology is absolutely exploding at the moment.
I can imagine, Yeah.
And if we look at the global 3D concrete printing market share by region, you'll definitely see that Europe is by far leading, where Germany, France, the UK, and Denmark are included as the leaders at the moment. In the Americas or North America, the USA and Canada have quite a few companies and quite a few research institutions that are involved in this. Then the Asian Pacific, we see China, India, and Japan that have already commercially made this technology available. And then Latin America, Middle East, and Africa is sort of conglomerated together in its own category. And this is largely due to the fact that we are a developing country where high capital investment is a barrier to enter the market. However, as you see, the Asian Pacific is expected to grow at the highest rate during the forecast period. So what this means is that developing countries are realizing that there's a need for this technology, or that there's potential value that can be added, and they've started investing and implementing methods to sort of harness the advantages of 3D concrete printing.
Now, I take it, I mean, look, it allows for simpler construction, easier construction, and quicker construction. And you know, besides the fact of, you know, your free flow. So, yeah, I can imagine that this will definitely start booming in the next couple of years. And yeah, I'm definitely looking forward to seeing this play out. Very interesting concept. Yeah.
Yeah, thank you very much. So then just a little bit more on, I've shown you the global market. However, in the African market, we've only seen projects undertaken in Morocco, Nigeria, and Malawi. We haven't seen in any other regions. However, if we look at the housing units needed to fill the current backlog in the top 10 countries that have sort of the biggest housing crisis at the moment, there's 17 million houses needed in Nigeria, and the urban population is expected to increase by 58 million by 2030. So there, and this is synonymous for all, you know, the DRC, Tanzania, Ethiopia, and then even South Africa. We have a housing backlog of 2.3 million units and an expected urban population increase of 8 million.
8 million, I see that.
So this is not really getting any better for us at the moment, and we really do require innovative solutions to solve this problem. And on this topic, so what's the African opportunity? The UN ratified 17 Sustainable Development Goals, which are largely focused at, obviously, how can we sustainably develop and how can we move forward together. And sort of, we don't have all the answers, but something that we heavily rely on is the triple bottom line of sustainability. So when trying to generate new innovative solutions, how to ensure that you have social development, economic development, as well as a positive impact on the environment. So in this sense, we have an unemployment rate of 28.5% in South Africa, and we largely rely on high volume, unskilled labor. So if you're familiar with the construction industry, this is sort of the approach that we've adopted, and it's part of the National Development Plan. However, employing 3D concrete printing provides the opportunity for sustainable job opportunities to be created. So this is a new technology that sort of has an element of a skilled operator that has to be able to operate this, but you don't need any formal training. So you'll be creating skills transfer for your employees. Furthermore, this is not as physically strenuous as conventional construction. So gender equality is something that we could be looking at to see more females in the construction industry.
Definitely.
And then directed career paths, because you sort of moving into this new realm of construction, there will be the opportunity to pursue this path that you've sort of embarked on. And then ultimately, as I said, we have a massive backlog, so address the housing issue. And housing is a basic need And then this provides us ultimately the opportunity to eradicate poverty in the South African context. If we look at economic development, the two sustainable development goals that are most applicable is decent work and economic growth, as well as industry, innovation, and infrastructure.
Yeah.
So I briefly skipped over that, but 3D concrete printing offers reduced time and cost with your construction. So theoretically, if you think about it, if you're reducing the cost and the time of a construction process, you could theoretically produce more projects or take on more projects in a shorter amount of time, therefore creating more jobs. And this will allow us to deliver on the critical infrastructure that we need. So we'll be developing our infrastructure. We'll also be creating a new market. This is something that I sort of want to reiterate or place some emphasis on. A lot of people are apprehended by us digitizing the construction process. But something that I really would like the audience to bear in mind is that introducing new technology doesn't cause us to omit our current practice. Essentially, what we'll be doing exactly is we'll be creating a new segment for new projects and new jobs, sort of increasing the amount or our capacity to produce in the construction sector. And then ultimately we are driving innovation. With the current, ecosystem of digitization and Industry 4.0, we have a very, slow or lethargic construction industry in terms of change. We don't really embrace new technologies so readily. And I think it's time that we start considering new opportunities and see how we can harness these for a positive impact.
Exactly. I mean, look, if you see the rest of the world, I mean, like you just showed us the example now. You've got Asia and you've got Europe and the US that's moving ahead with the technology. So I think for us to then keep up with the rest of the world, and then to then also make sure that our infrastructure is at the same level as everyone else, we need to then definitely look at adapting this technology and changing our way of thinking. Because I mean, if you look at some of our codes and standards, some of them are still the same from the 1970s and 80s, and we haven't necessarily updated some of them. So I mean, come back to road construction. We're still sticking to your traditional, sub-base, base, asphalt. Now we've got new technology with asphalt, where you're mixing asphalt with rubber and fibers. And sometimes the guys are also introducing, your geofabrics within the layers of the road, so that you reduce the need of, earthworks. So yes, there's all this new technologies coming out, besides this field, in just civil engineering in general. And we need to be, more effective in the way we do things. And definitely this is one of them. And we need to move forward with our way of thinking and construction methods. So
absolutely. And then something else that's very important for us is to consider the environment in our construction endeavors. So the sustainable development goals that are applicable in this case is sustainable cities and communities, responsible consumption and production, as well as climate action. So some of the advantages of 3D concrete printing is reducing the amount of material that you require and the amount of waste that you produce. So you can think, if you are precisely depositing material where you need it, creating cellular structures, you're ultimately reducing the amount of material required to resist certain loading. And then because it's a digitized process, you're minimizing the waste and the amount of rework that you require. This in turn allows us to reduce the CO2 emissions, ultimately creating a smaller environmental impact and allowing us to mitigate climate change, or to do our bit as civil or structural engineers for the greater good of the environment, and ultimately sort of
it is each of our responsibility to make sure that we contribute to the environment. We look after the environment, not only for us, but for our kids and grandkids and then the future generations. The thing is, there only is one Earth. I know we've got our scientists and astronauts out there looking for other planets to colonize, but when will that happen? When will it take place? We don't know. So until then, we need to look after the one Earth that we do have. So definitely, environmental, no question about it. We need to look after the environment, and whatever technology adds to that, we need to give it the light that it deserves. And this is one of them, and it has quite an impact from what I can see. I take it you're reducing material use, material waste, and you're being a bit more effective in the way you're building. So definitely, it has quite a big tick in terms of environmental impact from what I can see.
Yeah, absolutely. So I hope you enjoy this presentation, sort of a general overview of what 3D concrete printing is all about. If any of you have any questions, feel free to contact me on my email address at the bottom, and I'll gladly respond. And let's have an open-ended conversation on this. And what does it mean for the construction industry and potential applications? How can we use this? How can we add value? And hopefully we'll see South Africa embrace this new technology.
No, definitely. We need to at least make a big impact and at least lead in this technology within the South African environment and even Southern African environment. Thank you for coming and then having this discussion with us. And to the audience out there, guys, if there's any questions, give us a comment here on YouTube, or if it's on LinkedIn, whichever platform you are connecting with us on. Drop in your comments, raise your questions. You've got Marchant's email address. Drop him an email as well. And so I think definitely we'll look at coming back to you again, Marchant. I think there's two specific topics I'm thinking of. One around the maybe the concrete mix design, and perhaps maybe something on reinforcing. So we'll come back maybe at a later time to have a look at those presentations as well. And again, this is South African innovation at its best. You've taken an international concept that's out there. You've developed your own printer, and you've taken the software that's out there and you've developed your own. So again, like I said, classic South African innovation, and this is what we're all about, and together we move forward and towards the future. Long term, where do you see this thing ending up for South Africa? I don't know if you have any crystal ball that you can have a look at. Maybe go to the moon with it or something, or build something on the moon?
Yeah, well, actually, there are two companies, Apis Core and Icon, that have already indulged in this idea of yours that you're sort of hinting towards. They've actually collaborated with Big Architecture, so that's the Bjarke Ingels group. And they're looking on creating habitats on Mars and on the moon. These projects are funded by NASA. So that from a sort of intergalactic point of view, there's certainly scope. In the South African market, I definitely see us taking smaller steps at first. Looking
you need to crawl before you run.
Absolutely. So I think we'll be looking at the existing value chain in the construction industry and looking to add value where we can with certain components, and then systematically move forward, gain traction in the market, and then ultimately where there's a need, this technology would be adopted.
Oh, definitely. I think we must make a plan and then get to the moon first and set up our building there first.
Put up the South African flag.
Yeah, definitely. No, we must be there. Thank you, Marchant. Thank you for joining us. And to the audience out there, thank you for watching the video. We hope that you enjoyed it. There will definitely be more follow-ups coming soon. There's potential to take up further topics with Marchant. And please, again, like the video, subscribe to the channel, and turn on your notifications so that you will be notified as soon as we put up new videos on maybe more on this topic or other topic. And if you have any suggestions for any other specific topics that you want us to touch on, please drop us a comment in the comment section below. We will definitely follow up with a video just to address your specific wants and needs. Thank you once again.
Thank you very much for having me, Tauqeer.
Thanks, Marchant. Bye.
Bye-bye.